In this lecture, we will put some context into why the field of statistics is important. We'll begin by distinguishing between statistics and experimental design. Then we'll define some key experimental design terms and identify these variables in the description of an experiment. And finally, we will describe the relationship of statistics to epistemology. Statistics are used as tools to make conclusions from observable or measurable changes. These changes are often manipulated in the context of experiments. Experimental design is what we call the process we use to manipulate or observe changes. Within the field of experimental design, there are several key terms. First, experimental design is all about measuring or observing variables, or various things that can vary. Two types of variables which are linked in experimental design are independent and dependent variables. Independent variables are the grouping factors in experimental designs. For example, a researcher may be interested in the difference between males and females on reported attitudes towards having children. In this example, the independent variable is gender with two levels, male and female. Another researcher might be interested in comparing 8th grade students to 9th grade students' responses on a measure of self-esteem. In this case, the independent variable is grade with two levels, 8th and 9th grade. Independent variables can have more than two levels. For example, if the independent variable is marital status, a researcher may be interested in 4 levels: divorced, married, never married, or widowed. Dependent variables are the things a researcher measures or observes. Sometimes the researcher manipulates the independent variable to see if the manipulation affects a change in the dependent variable. In these cases, the levels of the independent variable may correspond to a treatment. If the dependent variable is attitude, the researcher may be interested in seeing if the amount or type of feedback given to students during a math class affects the students' attitudes towards learning math. In this instance, the researcher would likely choose 2 different class periods for the independent variable groups. In one class, he could provide efficacy-enhancing feedback to students during lessons. In the other class, he could refrain from any efficacy-enhancing feedback. Then, he could measure the students' attitudes towards learning math to see if there was a difference between the 2 classes. In this case, the independent variable is type of feedback with 2 levels and 1 class in each level. Efficacy-enhancing feedback is the first level, and control group could be the name for the second level. The dependent variable would be attitude towards learning math. Other dependent variable examples may be preference, time to complete a reading test, and life satisfaction score. Let's look at a specific example. 30 females were divided into 3 equal groups. One group was taught how to concentrate on their breathing. A second group was told to imagine that the day was very hot and that they would be allowed to place their hand in cool water. The third group was told nothing. All 3 groups placed their right hand in buckets of ice water for 1 minute. Afterwards, they rate their pain on a scale of 1 to 7. Can you identify the dependent and independent variables in this design? Then, try to identify the levels of the independent variable. When you're ready, restart the video. In this example, the dependent variable is the women's self-reported pain levels, because that was the thing the researchers were measuring. The independent variable could be called type of instructions given, and there are 3 levels, each level represented by one of the 3 groups. Level 1 was the group that received instructions of controlling their breathing. The group who did the mental imagery exercise about the hot day was the 2nd level, and then the 3rd level acted as a control group and received no specific instructions. A 3rd kind of variable in experimental design is the irksome extraneous variable. Extraneous variables are troublesome to researchers because they can affect the viability of conclusions because there may be alternate explanations to why a change was perceived. For example, an extraneous variable in the previous slide's example might be pain sensitivity. It would be nearly impossible to control for the variances in pain sensitivity in all 30 women. Thus, it is possible that these differences in sensitivity may have affected how the women reported their levels of pain, regardless of the type of treatment they received. So why do we bother doing research and using statistics if we can't control things? Well, one might argue that it's human nature to desire understanding of one's surroundings. These understandings come from both reasoning and experience. If we use reasoning to make meaning from our experiences, thereby developing a theory about the experience and its meaning, we're practicing epistemology, or the study or theory of the nature of knowledge.